Kazmi, and I will be making the presentation today. I'll bring up the slides here. Can you see my screen?
You don't.
You don't, okay. Then I have not done something right. Okay. Actually, I need to do okay. Can you see it now?
Yeah, we can see that.
Okay. Okay. I don't know if I okay, hopefully this is better. So today I'm going to talk about some geotechnical challenges for a roadway highway interchange project, which is called the I-95 and US Route 1 interchange. This project was constructed by Virginia Department of Transportation in connection with Woodrow Wilson Bridge replacement project in Alexandria, Virginia. A little bit of a very brief introduction for me. Again, my name is Qamar Kazmi. I'm a principal and senior vice president with a company called Travel Engineering. So we're going to talk about a little bit of a background of the project. I'll present the site conditions and some of the geotechnical challenges associated. And I will also present some of the measures that were taken for improvement of the ground. This slide had been a little bit problematic yesterday also. You're not able to see. Let's see if I can okay, I don't know if you can see a cursor now. Okay. Okay. Basically, the graphic is not being shown here. It's the Washington D.C. area. Let's see if I can go to next. Washington has never been that dark. Let me actually go. I'm trying to go to the next one. Okay. So this is the Washington, D.C. area map that you see. There is this river. I don't know, Asma, can you help me? How do I get that laser pointer?
Go to annotate.
Annotate, okay.
Mm-hmm.
And then okay.
Do you see tools now?
Oh, okay. Different tools.
If you accept the request that I just sent.
Okay, proof. Okay.
And now you see that arrow?
This arrow?
Yeah.
Pointer. Okay. Okay, here's the pointer, I guess.
Yes.
Okay. So here is the Potomac River that flows through Washington, D.C. This part is Maryland over here, Washington, D.C. over here, and Maryland over here, and this is Virginia, which divides, the river divides. On the west, you have got the state of Virginia. may not be able to see it very well, but there is a roadway highway. It's called the Beltway or I-495, which crosses over the Potomac River on the south side here. This is the Woodrow Wilson Bridge, which was an old bridge, more than 50 years old, and it had seen more traffic than it was actually designed for, so that needed to be replaced. And that replacement, of course, needed to be done by still keeping the traffic moving, because it's a major highway. You could not stop the traffic. So the idea was to build another bridge a little bit south of the existing bridge, and then convert the traffic, move the traffic over to the new bridge, and then demolish the existing bridge. When you do that, when you move the bridge, that means that the connection of the roads on either side needed to be redone. The other interchanges that were there, on 2 interchanges on each side, needed to be modified. So the project that we are going to talk about is the first interchange on the Virginia side, which is here, like where you see the arrow going north to south, is Route 1 or Route 1. And then this is the I-95 and 495, the Beltway. Okay. Trying to forward the slide, but I'm not doing it. Do I need to get out of the annotation tool to do that?
Now try that.
I don't know what's going on here.
No, it's not, the slides are not moving. It's
Right. I'm not being able to forward the slide. Looks like as if, almost as if I don't have a controller, so I see a cursor, the arrow, going over here. Okay. So, okay, how about if I did stop annotating and then maybe that way? Oh. Okay. Okay. So this is a close-up of, this is where the Woodrow Wilson Bridge is. Let me make sure I get the annotation thing. Okay. So this is the Woodrow Wilson Bridge, and this is Route 1, rather this right here, and that's the interchange that we are talking about. This is the interchange that we were replacing. And this over here is a stream called Cameron Run. Okay, so this is a complete reconstruction of the existing interchange, again, while maintaining traffic. All the ramp movements were modified, and there was also an additional ramp for connections for future HOV lanes, which is the high occupancy vehicle lane, 2 or more passengers in each vehicle. A number of retaining walls and sound barrier walls extensive ground improvement program along the north and south limits of the main roadways, and we'll talk about it. And it also included, of course, the main bridge replacement for Route 1. So some of the features of the interchange include approximately 36 lane miles of the roadway improvement. So it's like four lanes in each direction, and about 320 square yards of roadway paving, and 23 vehicular bridges and 2 pedestrian bridges, totaling 990,500, or almost 1 million square feet of bridge deck. I don't need to go through this. You can see it was a fairly substantial program. The widening of the highway, again, when the replacement was done for the Woodrow Wilson Bridge, that opportunity was also taken to widen the highway to take traffic for future. Because of that widening, there were a number of displacements. 1 high-rise residential unit and 3 low-rise residential units were demolished, and 2 office buildings were demolished. The high-rise I'm talking about, it was probably a 14, 15-story high-rise. So this gives you, this is a photograph of the original interchange. By the way, this project was done back in about 1999, 2001, 2002, in that time frame. On the, let me go again to the annotation here. So over here is the Potomac River. North is this side. South is over here. This is the main beltway, I-95, I-495, and the bridge that goes over I-495 is the Route 1 highway. And you can see, there are a number of ways, you get around. Okay, so physically it was a 1.36 mile long section, and widening of the 495-95 beltway, and a new Route 1 bridge over the I-95, and all the connecting ramps. As I mentioned, the owner was Virginia Department of Transportation. The general engineering consultants were Potomac Crossing Consultants. Section designer was H&PB. Geotechnical consultants were Haley and Aldrich and Virginia Technical Services. I used to work for Haley and Aldrich at that time. And then later on for the construction, Rato Incorporated was the contractor for soil mixing. So the site is a low-lying estuarine environment. So a lot of alluvial, recent soil deposits, soft soil deposits. Ground surface generally less than 10 feet mean sea level. As I mentioned, there is Cameron Run on the south side. Actually, on the north side, there is Hoof Run, which you will see in a subsequent slide. And because of the estuarine environment, a number of wetlands, tidal flats located in the southern portion of the site. So the challenge was that we had soft alluvial soils, which created issues with respect to slope stability and settlement. And also, there were a number of existing adjacent infrastructure that needed to be protected. Because this is a widening, so there is an existing highway, and the widening is being done right next to it on each side. So that needed, those adjacent structures needed to be maintained. And of course, the maintenance of traffic through all this. So this is an aerial photograph pre-beltway construction. So you can see that there is no beltway here. Again, I'll go to the annotation here. And so there is no beltway over here, but Route 1 is over here. And Washington Street, which is another street further east, is over here. Hoofs Run, which is another stream, goes over here. Cameron Run is over here. Okay. So, okay, this is a 1962 aerial photograph, and you can see that the interchange, Route 1 interchange here to the right side, has been completed. This is the original interchange we're talking about that was constructed in 1962. Work is progressing, as you can see, further to the west towards where the Hoofs Run is written, and the next interchange there is Telegraph Road, which is a little bit under construction. And this one shows that the Telegraph Road interchange is also completed on the left side of the photograph. So this is the area that we will be talking about. The Beltway, outer loop, inner loop. There are two sets in two directions in which traffic is going. And between, this is a 1974 aerial photograph, which shows that after the construction of the Beltway and all this Route 1 interchange and so forth, there were some further additional construction on both the north and the south side. On the north side, there was the Alexandria wastewater treatment plant and some other structures, and these were the three buildings, large buildings that I talked about on the south side, you will see. So the northmost of these buildings in the oval had to be demolished for the construction of the new interchange. Okay, so I think there was another slide which somehow was not showing up. The typical conditions that we had are, we had a fill at the top, which was about 5 to 10 foot thick, and an alluvial clay, organic clay, 5 to 20 feet thick, then alluvial sands, 5 to, either not existent or up to 5 foot thick. And then there were terrace sand deposits, these are called, which are essentially Pleistocene age sand deposits. So these are very competent materials. As you can see here, the angle of internal friction P is about 38 degrees. And below that, we have Cretaceous age hard plastic clays, locally known as the Potomac clays. So the challenge that it was there was that you have this profile, and there's an existing highway, and you need to widen the highway, construct a fill right adjacent to it. So as you know that if you did that on a very soft deposit, you can see here the undrained shear strength of the alluvial clays was on the order of, and I apologize for the typo here, it should be 100 to 600 pounds per square foot rather than cubic foot. So really very soft material. So in the original Beltway construction, there was fill between Telegraph Road and the Woodrow Wilson Bridge, which was the bridge over the Potomac River. And there were some ground improvement measures that were taken. And that included actually removal of the soft clays and the fill. that you saw in the previous profile, and that means that basically they went in there and excavated all of that soft clay, because otherwise you would not be able to construct the embankment for the highway. However, in one portion, which probably was the first use of sand drains in the United States, sand drains were used and surcharge was placed to improve the ground for the construction of the highway. And we have information on that from published papers. They were 18-inch diameter sand drains, 9 to 10 foot spacing, and over a section of about 2,700 feet and about 200 foot pipe area. And they had placed 10 to 12 feet of surcharge, and they required toe berms for stabilizing the embankment. So you can see here the okay, so you see this is where the existing beltway was, the highway. And then you have the ground dropping down to Qamar Run, another depression over on the north side. So the original ground surface during construction of the original beltway was something like the upper black line, dashed line that you see. So to construct, and the alluvium that you see probably was the lower dashed line going across here. So a lot of alluvium that was there, and essentially they had an open area, so they went ahead and excavated all this material at relatively mild slopes, and just went ahead and went all the way down to the terrace sand deposits, excavated it all out, and then placed the fill to construct the embankment. Okay. So in the other areas where they could not remove the alluvium, they used sand drains to surcharge the existing soils, and then placed the highway fill. So for our project, where it was a widening of the beltway and the reconstruction of the Route 1 interchange, we used a number of exploration techniques, SPT test borings, standard penetration tests, collected a number of undisturbed samples from borings, tube samples, different types of tubes. We did some bone penetration test soundings and also dilatometer soundings. Dilatometer soundings are especially useful for evaluating the settlement and consolidation properties of soils, of soft clay or fine grained soils. This simply gives you an idea of the number of explorations, various boring soundings that were done in this about 1.3 mile section of the highway, so that we could get a better understanding of what the subsurface conditions are like. The soil laboratory testing included various classification tests, chemical tests of the soils, and you'll see in a minute, why that is important. Consolidation, one-dimensional incremental loading tests, constant rate of strain consolidation tests, and we did the consolidation tests both for vertical consolidation as well as for horizontal consolidation, so that the seepage is occurring either vertically or horizontally, and also the horizontal and vertical permeability of the soil at the site. And again, continuation of soil lab testing, shear strength tests, various, including UU unconsolidated undrained triaxial tests, isotropically consolidated undrained triaxial tests, direct shear tests, and K-naught consolidated tests. This slide gives you an idea of what the soil profile looked like with respect to the moisture and organic content. So on the left side, you see the moisture content, and you see the ground surface we talked about was generally 10 feet or less below sea level, mean sea level. And you'll see that in the upper portion to about elevation 0, that is fill that we encountered, that was placed. And then usually 0 downward to about -20 is the alluvial soil deposits. So you'll see the moisture content of these soils from 0 to -10 foot elevation is generally on the order of 50%. And then when you go to elevation -10 and below, average might be around 80% moisture content. And similarly, organic content of from 0 to -10, you'll see that that is, almost in the range of 5 to 10%. Of course, it is much higher in other areas. And again, higher organic content, often, reaching almost 30-40% in many locations. This is a plot of the over-consolidation ratio, which I'm sure you have been exposed to, since I understand these are your third and fourth year students. You have had some course in soil mechanics. So the over-consolidation ratio is the past pressure that the soil has seen compared to the ratio of that, of the past pressure the soil has seen compared to the existing pressure. So the over-consolidation ratio, the soils have been subjected to 1.5 to 2 here you see, but you see a number of soils between -10 and -30 where the OCR is very close to 1, which means that they are normally consolidated or nearly normally consolidated soils, and they have not seen any other pressures. Which also means that if you were to load these soils, they will undergo very significant consolidation and settlement. This is a plot of the consolidation ratio for the different soils, and you'll see again, on the order of 0.23 or so in the upper soils between -5 and -10, and more in the range of 0.35 for the consolidation ratio below elevation -10. The approach for ground improvement that we had was to use PV drain or prefabricated vertical drains, especially on the northern side, and surcharge them. That is to apply loading beyond what the final ground surface is going to be, so that you can have additional settlement that will occur. Now, and then we had deep mixing of soils to improve the strength of the soils with and without surcharge in areas where we could not use prefabricated vertical drains for consolidation settlement. That is that those soils, we expected that the settlement to take so long that it was not practical to do it even with vertical drains. And that's why mixing and improvement of that soil was necessary. This gives you a layout of where you see the blue or the cyan is where the prefabricated vertical drains were used, and the pink are areas where the deep soil mixing was done. There were 2 test embankments that were constructed. The red star shows the location of the PV drain test embankment, and the blue star on the south side shows the location of the deep soil mix test embankment. These were generally about 50 feet wide, 100-foot long test embankment just to monitor that and see what sort of rates of settlement we are getting and the properties of the soil. So typical cross-section in the area of the sand drains, where we use sand drains for improvement. You see here is the existing beltway in the center, and on the south side, you see further extension of the beltway. The prefabricated vertical drains are shown, and then you have a soil cement mixing to stabilize that material, because otherwise you will have a slope failure. On the north side again, you have prefabricated vertical drains, and this is an area of where the sand drains were used in the original construction. You can see in the center. And these were the existing conditions for one of the locations where the removal of the previous fill was done. And in the widened embankment, you see on the north side, left side of the figure here, the prefabricated vertical drains were used, and surcharge was placed to be able to construct the embankment. And it so happens that on the south side, we had soil cement column, and also there was a ramp going in, which was pile supported on that side. And we'll have another view of this. This is an area where there was muck removal. You can see, the soil removal that was done on the left side of the figure. And this is for the south side of the project, where a number of soil cement columns were installed. The left portion, which is widely spaced, are soil cement columns that were installed in a grid pattern, more for control of settlement of the material due to the fill placement. And the soil columns that you see, which are very closely spaced on the right side, are essentially buttresses to improve the stability of the soil and to prevent a slope failure. So what is deep soil mixing? It is an in situ blending of cementitious material with soil using rotating shafts with cutting tools and mixing with paddles and augers. And it can be done both as a dry method or a wet method. And you can have multiple shafts, and I'll show you some of the equipment that was used for it. And you introduce cement or lime, or a combination of lime and cement, and you of course have the chemical reaction, pozzolanic reaction, and that improves the soil properties. It increases the strength, and it increases the stiffness of the soil so that the settlements are then controlled. There are different ways you can use this. Projects you can use deep soil mixing for improving the ground. If you have soft ground, you have a seawall foundation, you can use improved ground and create that. Breakwater, abutment, and so forth. I won't get into it. But just to give you an idea of what different projects of construction could be constructed by using improved soil by deep soil mixing. So this is showing you what are the modes of failure. So you see the embankment in the center of the site. Let me annotate it again. So this is where the construction of the embankment is occurring. And you can see a slope stability analysis failure circle. And this is just conceptually to show that as due to the placement of the embankment, as there is the movement of the soil, the soil columns on the right side here, where you see it says flexural failure, these are getting stressed in shear, and that's how they are failing. Whereas on the left side, these columns are actually undergoing tension failure. So when you design, you have to design these the soil cement columns such that they would be able to withstand the stresses due to the placement of the embankment in flexural mode of failure on the right side, and also design it to be sufficient for tension on the left side here. Okay, so this is an using slope stabilization with individual soil cement column, and deep soil mixing can be done both by single columns, generally for settlement control, and shear walls or buttress of overlapping columns for slope stability. For the Route 1 interchange project, we had this, again, I would not get too much into the details, but this is the SCW is the soil column wet method, and the specification that we had was that the average strength of the soil cement mixed column should be 160 psi, with a design value needed of 140 psi, and minimum that was allowed was 100 psi. But for any given core hole, the average was 160. So this is again, now this is showing you also the plan view at the bottom. So you see that a number of individual columns on the left side of the screen, which are widely spaced, which is where settlement is controlling. And then you have a transition zone where the active earth pressures will be acting, and the shear zone, and then on the right side is the passive zone. So in plan, you'll see on the right side, there is soil cement buttress, and a series of soil cement columns. We call it secant pile type installation, where they are actually overlapping to create a buttress that is going to resist the soil from failure. So in the Route 1 interchange, again, we had 3-foot typical spacing of these columns, and at the bottom you'll see that that's where the buttress in yellow, that's where the buttress is being placed. And essentially the way the control is, I see that the folks are stepping out. Looks like the talk is not all that interesting. So I'll try to hurry up here. But I would also encourage, if there are any questions, I'm going to be here so we can talk about questions you may have and go over things.
No problem.
Okay. This is again for settlement control, and what happens is that as the loading on the softer material, which is in between the columns, is applied, the load is shed on to the columns, and that's what takes the stress. So it's kind of an arching effect through the soil, and that's what keeps the settlement under check. So this is a deep soil mixing rig. You see, for scale, you can see at the bottom, that's where a man is standing. That's the scale of this equipment. And this is deep soil mixing in progress, where this particular rig happens to have 3 shafts, and you have soil cement being injected through these three shafts. It goes into the soil, and then it does the mixing and churning of the soil and comes up, and the whole soil, you basically have three soil columns by the time it comes up. And you have a batch plant on site for construction like this, which so you have an on the site mixing going on for the soil cement. Now, this is actually a aerial photo that I took from I think Google Maps or something, but it shows the current conditions. So you see let me get again the annotation here. Okay, so this is where the Woodrow-Wilson Bridge is located, and this is the interchange in question. So this is now showing a different configuration than what we saw at the start of the presentation. This is all finished, and it has a different flow. The beltway has been widened, and so let me get back here, stop annotation.
Like
okay, so now you don't have to wait too long. I would actually be more interested in questions. जी,
अच्छे तो शर्मा रहे हैं आपको?
हाँ, मुझे यही लग रहा है। तो आप कोई भी जो दो चार स्टूडेंट्स हो जो कि आप तो समझते हैं कि थोड़ा बहुत वो बात करना चाहेंगे, तो मैं उनसे बात करना चाहूँगा 1-on-1 और 1-on-5 और whatever कि इसमें, क्योंकि अगर कोई सवाल नहीं है तो इसका मतलब ये है कि प्रेजेंटेशन जो थी वो या तो बिल्कुल ही बोर थी या लोगों की समझ में नहीं आई. It may not be in sync with what the students have been exposed to. And if that's the case, then let's talk about it.
अब तो सीरियसली कोई आम सवाल है, आपने वो भी कर सकते हैं कि हमें क्या होता है, होता है.
आप ये भी सवाल कर सकते हैं कि आपके क्या चीज ओवरऑल क्या चीज नहीं समझ में आई. दैट्स परफेक्टली ओके.
अपने डिस्कशन दीजिए. मैं
I'm Rahil Shamim, student of the final year mechanical engineering.
ये इसको कैमरे को जरा सा ऊपर कर दीजिए कि आप बैठ जाइए ताकि आपकी शक्ल भी नजर आ जाए.
जी सर, my question is that what is the difference between piling and soil mixing?
Piling and soil mixing. Okay, very good question. Piling जो है, it is a much stiffer element. Usually piling जो है वो या तो precast होती है. आपको पाइलिंग के मुख्तलिफ पाइल्स का पता होगा कि जैसे प्रीकास्ट प्रीस्ट्रेस्ड कंक्रीट की पाइल होती हैं जो कि ड्राइव की जाती हैं. देन यू आल्सो हैव, और अगर आप लोग चाहें मैं आई कैन गो बैक एंड फोर्थ बिटवीन इंग्लिश एंड उर्दू, नॉट अ प्रॉब्लम. तो उसमें एक तो आपकी जैसे स्टील पाइल्स हैं, दे आर ड्रिवन. आपकी कास्ट इन प्लेस पाइल्स होती हैं जो कि पाकिस्तान में खास तौर से इस्तेमाल की जाती हैं, कास्ट इन प्लेस या बोर्ड इन प्लेस पाइल्स. तो ये जो बोर्ड इन प्लेस पाइल्स हैं फॉर एग्जांपल, वो रीइंफोर्स्ड होंगी और सारा जो आपका लोड है वो इन पाइल्स के ऊपर आएगा. दे आर फाउंडेशन एलिमेंट्स, दे आर सपोर्टिंग द सुपरस्ट्रक्चर. द डिफरेंस विद द सॉइल सीमेंट कॉलम्स इज that they are not a foundation system and rather they are a ground improvement system. So what they are doing is that you are putting in these elements at a spacing such that you are stiffening the overall soil matrix. And then when the load is applied, then that overall soil matrix, because it has now an improved ground, is able to support it. But it's not directly, you are not designing the thing for each element to support the full load of the structure.
So I am from construction engineering of NED. I want to ask you a very general question that as you discussed about this highway. So I want to ask whether कि ये सब काम सिविल इंजीनियर से, दिस इज ऑफिस वर्क, डिजाइनिंग वर्क, तब ये काम कंस्ट्रक्शन इंजीनियर करेगा या कंस्ट्रक्शन इंजीनियर का इसमें क्या वर्क होगा?
कंस्ट्रक्शन इंजीनियर जो है वो उसको एग्जीक्यूट करेगा. इसमें जो लोग इन्वॉल्व होंगे उसमें बहुत सारे लोग इन्वॉल्व होंगे. बिल्कुल शुरू में जो है प्लानिंग की स्टेज पे होगा जिसमें ट्रैफिक इंजीनियर्स इन्वॉल्व होंगे टू फिगर आउट कि कितनी लेन्स एडिशनल्स में होनी चाहिए, कितना ट्रैफिक है एंड सो फोर्थ. और उसके बाद फिर डिजाइन इंजीनियर्स होंगे जो कि मुख्तलिफ डिसिप्लिन के होंगे विद इन सिविल. आपके ट्रैफिक के भी होंगे, प्लस ट्रैफिक या ट्रांसपोर्टेशन के, प्लस यू विल हैव जो कि सारा इसकी ज्योमेट्री जो है इंटरचेंज की फॉर एग्जांपल, वो ट्रांसपोर्टेशन इंजीनियर्स फिगर आउट करते हैं. उसके बाद फिर आपकी स्ट्रक्चरल इंजीनियर्स हैं जो कि मुख्तलिफ जो स्ट्रक्चर्स हैं, ब्रिजेस हैं, उनको डिज़ाइन करेंगे. जियोटेक्निकल इंजीनियर्स हैं लाइक माई सेल्फ, कि जो उसको सबसर्फेस कंडीशंस को एक्सप्लोर करेंगे, उसको टेस्ट करेंगे, उसको फिर रिकमेंडेशन देंगे जिसके बेसिस के ऊपर डिज़ाइन किया जाएगा स्ट्रक्चर्स की जानिब से। इसमें फिर कंस्ट्रक्शन इंजीनियर्स का जो है वो काम उस वक्त आएगा जब के एक्चुअल प्रोजेक्ट बन रहा है, तो वो उन प्लान्स को लेते हुए दे विल एग्जीक्यूट द प्रोजेक्ट एंड दे विल कंस्ट्रक्ट।
तो बेसिकली कंस्ट्रक्शन इंजीनियर का काम फील्ड वर्क होगा।
जी हाँ।
थैंक यू।
Sure.
Good evening, Mr. Qamar.
Good evening.
Sir, I am final year mechanical engineering student. I was more interested in the rigs that were being used there and different machinery. Can you elaborate? Can you tell different types of machines that are being used there, for various purposes?
Are you specifically asking about the equipment that was used for this project?
Yeah, for this project in specific.
Okay. So, and again, what I am showing here is more just the soil mixing equipment. So that is basically this piece of equipment that I had shown that you see now on the screen.
Yeah.
This is what essentially was used. Actually, I have to take it back. This is an example, but it is not the one that was used. The one that I believe was used was single shaft method. So it's this one. This is from this job site. Okay, so it's one shaft. You have a shaft in which there is a jet of cement lime mixture, which is mixed with the slurry, and that slurry is introduced in the ground under pressure, and the shafts are rotating so that that cement soil mixture is mixed with the soil surrounding it. And because you have now the soil getting mixed with the soil cement, it becomes a stiffer element. And you can adjust the pressure with which the slurry is injected into the soil, and that determines what will be the diameter of that soil cement column.
Okay.
But essentially, and let me show you a couple of other slides. This is, for example, after the soil cement column was created, basically we went back, cored the soil cement column, and did tests of strength testing to see what was the strength of the material, unconfined compressive strength of this material. So basically, it's just like as if we were doing a soil or a rock coring. So here's actually that soil which, as I said, had a strength of about 100 to 500 pounds per square foot, which is a really, if you had that kind of a soil, it would just you won't be able to have a core like that at all. It would just disintegrate or deform significantly. So, and here the sample is being prepared for testing. So you can see it's a saw is being used to cut the ends of the sample. So that's the kind of strength from going from about 100 to 500 pounds per square foot. Like I had mentioned, we had a minimum required strength of 100 psi, so pounds per square inch.
It's okay. I think I will brief you much more about the equipment. Okay. Now I have one question. About this, do you remember that once when I was in industry for highway, and you were working for
right.
At that time we were trying to make a bridge, which we call as Thana Khan Bridge.
Okay.
On superhighway.
Okay.
But that project failed. Why?
I lost you there, Itafa. I cannot hear you.
That particular project where we were preparing that bridge in Thana Khan on superhighway, that complete project was demolished. Why?
Oh, you mean the whole project was scrapped?
Yeah.
I mean that was not just the. I mean not just the bridge at Thana Khan. I'm not myself familiar with that, but I know when I was working with engineering consultants, there were two different sections of the Indus Superhighway project that we were doing. And I remember, I mean, I had gone and stayed in Dera Ghazi Khan for a number of months when we were doing the investigations. I personally, I remember that whole project at that time, and we are talking about 1977, 78, you know.
That's correct.
That time frame. I remember that the estimated construction cost of that project at that time was $500 million.
No. Okay. No, I'm not asking that question. What I'm saying is that why Thana Khan, that intersection, that was not acceptable to the people. Why?
That I don't know. I'm not familiar at all with especially the Thana Khan bridge.
Okay, thank you.
Sorry. Right.
I'm Abdul Ansari from final year mechanical engineering. And my question is this, that अभी आपने एक वो rig दिखाई थी मशीन
जी,
तो मेरा ये क्वेश्चन है कि ये ऐसी मशीन को नॉर्मल एरिया में यूज कर सकते हैं जहाँ पे लैंडस्लाइडिंग का इशू होता है?
हाँ, इस्तेमाल किया जा सकता है।
हाईवे कंस्ट्रक्ट जैसे बाईपास वगैरह?
जी बिल्कुल किया जा सकता है, लेकिन ये कि सॉइल कंडीशंस ऐसी होनी चाहिए कि जिसमें उससे फायदा हो। तो दैट्स द की थिंग, ये सॉइल कंडीशंस कैसी हैं। फॉर एग्जांपल, अगर आपके पास रिलेटिवली शैलो रॉक है और आप जब कंस्ट्रक्शन कर रहे हैं तो यू हैव मोर ऑफ रॉक स्लाइड इश्यूज, तो फिर इस किस्म के इक्विपमेंट जो है वो काम नहीं करेगा, उसमें कोई फायदा नहीं होगा। ये जो है ये सॉफ्ट ग्राउंड कंडीशंस को बेहतर बनाने के लिए ये पीस ऑफ इक्विपमेंट है।
लैंडस्लाइडिंग हो अगर एरिया, तो वहाँ पर ये मेथड यूज नहीं हो सकता?
नहीं, होने को बिल्कुल यूज हो सकता है, लेकिन ये कि इन दी ओवरऑल कॉन्टेक्स्ट बिल्कुल लैंडस्लाइड वगैरह के लिए भी ये चीज़ इस्तेमाल की जा सकती है, लेकिन ये कि उसका बाकायदा एक डिज़ाइन होगा, उसमें जो ज्योमेट्री है उसको इम्प्रूव किया जाएगा, प्रॉबेबली एक डिज़ाइन किया जाएगा, कुछ बर्म डिज़ाइन की जाएगी टू स्टेबलाइज द ओवरऑल स्लाइड, और उसमें बिल्कुल इस्तेमाल किया जा सकता है क्योंकि इट्स अ ग्राउंड इम्प्रूवमेंट मेथड। तो ओवरऑल जो मैट्रिक्स है, सॉइल मैट्रिक्स जो है, फॉर एग्जांपल अगर ऑन द रेजिस्टिंग साइड ऑफ अ स्लाइड, और मुझे पता है कि आप मैकेनिकल के हैं तो यू मे नॉट फॉलो व्हाट आई एम सेइंग, लेकिन जब एक एम्बैंकमेंट जब कंस्ट्रक्ट किया जाता है या एक लैंडस्लाइड जब हो रही है, तो एक साइड जो है वो ऊपर वाली जो है दैट इज ड्राइविंग, and the side that is below in the lower portion is the resisting side. It is resisting the movement of that slide, either through friction or cohesion or whatever. और वो portion है कि जिसको आप further reinforce करते हैं by soil mixing या दूसरे method से, और that's how you overall improve the landslide situation.
Thank you.
Any other question?
Welcome, sir. So I have a question. I've heard about the skin friction in constructions, but मुझे पूछना था कि क्या skin friction के advantages हम लोग किसी production machinery की production में ले सकते हैं, जैसे कि robotics और ऑटोमोबाइल्स में।
क्या आपने कहा स्किन फ्रिक्शन?
जी, स्किन फ्रिक्शन।
स्किन फ्रिक्शन जो है वो बेसिकली जो इस्तेमाल किया जाता है आपके सिविल के जो लोग हैं वो आपको बताएंगे, स्पेशली इन कॉन्टेक्स्ट ऑफ डीप फाउंडेशंस, जो पाइल फाउंडेशंस है। तो पाइल फाउंडेशंस की जो कैपेसिटी डेवलप होती है वो पाइल्स आर वर्टिकल एलिमेंट्स कि जो या तो ड्राइव किए जाते हैं या वैसे इंस्टॉल किए जाते हैं। तो उसकी कैपेसिटी जो डेवलप होती है वो जनरली दो तरीकों से हो सकती है। एक तो ये कि एट द वेरी एंड यू हैव अ वेरी स्टिफ और हार्ड स्ट्रैटम, जैसे कि रॉक अगर है तो उससे एंड बियरिंग होगी, और अक्सर पाइल जैसे स्टील पाइल जो है ड्रिवन टू रॉक आर एसेंशियली डिजाइन्ड एज एंड बियरिंग एलिमेंट्स। लेकिन आपके अगर आप सॉइल में एक पाइल फाउंडेशन कर रहे हैं या ड्रिल शैफ्ट कर रहे हैं तो उसमें जो रेजिस्टेंस डेवलप होगा वो पार्टली स्किन फ्रिक्शन से होगा। स्किन फ्रिक्शन का मतलब सिर्फ ये है कि जो उसका सिलिंड्रिकल पोर्शन है पाइल का, उसकी जो सरफेस है उसका फ्रिक्शन विथ रिस्पेक्ट टू सॉइल, हाउ दैट इज इंटरैक्टिंग एंड that friction is generating a resistance. That's all skin friction is. So when you were mentioning कि किसी और मैकेनिकल उसमें इस्तेमाल किया जाता है, I was not sure कि आप किस चीज के बारे में कह रहे हैं कुछ। Can you repeat?
Yeah, I was asking skin friction जैसे soils में है तो मशीनरी soils में यूज होती है, जैसे sand, beach, तो हम उसको किसी मैकेनिकल डिवाइस के लिए एडवांटेज उसके यूज कर सकते हैं फॉर स्टेबिलिटी, और यू नो इन कंस्ट्रक्शन वाइज बहुत सारे हैं एडवांटेजेस।
ऐसा स्किन फ्रिक्शन को तो आप नहीं इस्तेमाल कर सकते, लेकिन ये कि आप जो भी अगर किसी कोई आप सिविल प्रोजेक्ट कंस्ट्रक्ट कर रहे हैं तो उसमें स्किन फ्रिक्शन इस्तेमाल हो सकता है इन टर्म्स ऑफ डेवलपिंग रेजिस्टेंस और कैपेसिटी। लेकिन ये कि सच स्किन फ्रिक्शन कोई ऐसी चीज नहीं है कि आप उसको लेकर के कहें कि भाई ये स्किन फ्रिक्शन अब जो है किसी और किस्म की मशीनरी में इस्तेमाल हो जाएगी। आप अगर एक फैक्ट्री में आपने मशीनरी लगाई हुई है तो उसमें तो जाहिर है कि नहीं हो सकती।
ठीक, थैंक यू। सर हमें क्वेश्चन दैट कंपैक्ट करते हैं, कंपैक्ट ड्रिल के जो कंपैक्ट करते हैं उसको वाइब्रेशन में उसको फाइन करने की कोशिश करते हैं, ये मेथड ज़्यादा बेहतर है या फिर इसको ड्रिल करके मिलाएं?
सॉरी सर, आप जरा फिर से रिपीट कीजिएगा, आपका क्वेश्चन इतना साफ आवाज नहीं आ रही।
ड्रिलिंग हम इसको ड्रिलिंग करके मतलब सीमेंट डाल के फाइन कर सकते हैं, तो कॉम्पैक्ट करना ज़्यादा बेहतर मेथड है?
कंपैक्शन जो है वो ज्यादा कॉस्ट इफेक्टिव मेथड है। सबसे आसान तरीका है कि आप अगर एक फिल प्लेस कर रहे हैं तो आप उसको कंपैक्ट करें। लेकिन अगर आप जैसे मैंने जो प्रोजेक्ट अभी बताया था उसमें आपके पास एग्जिस्टिंग सॉइल है जो कि बहुत सॉफ्ट सॉइल है, तो ये ऐसा सॉइल है कि जिसको आप कंपैक्ट कर ही नहीं सकते, ठीक है। तो उसमें यह है कि फिर आप इस किस्म के प्रोसीजर इस्तेमाल कर सकते हैं कि जिससे आप ग्राउंड को इम्प्रूव करें और ओवरऑल सॉइल मैट्रिक्स जो है वो इम्प्रूव जब हो जाएगा तो दैट विल increase the overall stiffness and it will be able to resist the loads better. You will have less settlement. You will not have a stability issue.
Okay.
Did I answer your question?
Yes, sir.
Oh,
thank you.
भाई कवर साहब, इससे पहले कि हम आपसे भी इजाजत में और आपको खुदाहफ्ज़ करें, just to change the mood, दो चार अच्छे अशार तो बोल दे।
ये तो कोर्स में नहीं था भाई।
कोर्स तो कोई बात कर रहा हूँ। अच्छा अशार यार, ओके गो फॉर इट।
मैं एक मुझे अंदेशा था कि आप इस किस्म की कोई हरकत करेंगे। तो मैं एक कविता सुना देता हूँ जो कि मैंने NED की तालिब इल्मी के ज़माने में ही कहा था, और स्पेसिफिकली 1976 में।
वही वाला तो नहीं है, मेमार वाला तो नहीं है?
हाँ, मेमार वाले ही है।
चलिए, अच्छा लगेगा मुझे भी।
दर्द की उसको दवा, जख्म का मरहम कहिए,
क्या बात।
तशनदा कौम के हक में जिसे जमजम कहिए, हाँ वही जात सरापा जिसे परचम कहिए, वो कदावर कि जिसे कायद आजम कहिए।
क्या बात, क्या बात, बहुत बहुत बहुत।
चलिए, किसी चीज पे तो रिस्पॉन्स मिला।